So these are iMac 3500 Zulus. If you look inside here, you can see what the pins are connected to. This little dish around here is connected to the grid. And you can see that all but 2 of the pins, 3 pins are connected directly to this dish, which is connected to the grid structure inside the tube. And these 2 pins here connect to wires that go to the filaments right in the middle of the tube. So I just marked those 2 pins with a felt tip pen, marked them F so I know what they are. So all I'm going to do is use my ohm meter to test for continuity on the filament pins first of all. That's pretty much a no-brainer. Okay, we got a good filament. Then I'm going to test for short between the filament and the grid. I'm going to go all the way up to 20 megs. No short between the filament and the grid. So that's good. Now I'm going to check between the filament and the plate. Now I'm going to check between the grid and the plate. Now all these grid pins are connected together, so you can use any one of them, it doesn't matter. So no short between the grid and the plate, no short between the grid and the filament, no short between the filament and the plate. So we're not going to get any immediate fireworks plugging that in unless there's gas in the tube which ionizes and creates a short. So now I'm going to go back and take a look at this thing here. Double check. This one's got a little phenolic base on the bottom that the other one didn't have. But yeah, those are the filament pins in the middle. So we'll do the same thing. Test for continuity, make sure the filaments are there, not blown up. If I'm smart enough to work a quick clip lead. Okay, that's okay. Now we're going to check between filament and... Why is this doing that? Select the range, any range. Okay, filament and grid, no short. Go up to the highest range. Nothing. Filament and, oops, filament and plate, no short. Grid and plate, no short. So we won't get any immediate fireworks with these tubes when we put them in. No obvious problems that you can measure with DC. So now I got my amplifier unplugged, take my big crowbar, go in here and make sure that that thing is shorted out. Go over here to the capacitor block and do the same thing. So we're okay there. So now what I'm going to do, I'm going to put a tube in here. Start with number 1. I just numbered these so I keep track of them. So I'll take number 1. I haven't done this yet, so do it now. Where's my paper towels? Make sure I'm recording. Let's see, what are we looking at? Yeah. Am I recording? I don't know if I'm recording or not. Yes. Okay. Just like any used vacuum tube, I'm going to put some deoxide on the tube pins, clean the socket, and I'll just run this in here and that'll clean the contacts on the tube socket as well. If I'm smart enough to insert this tube. Okay. First thing I'm going to do is check the filaments on these things, because the these iMac tubes have a reputation for turning into air bottles after a while. At least some of them didn't have the greatest pin seals in the world. So there's the filament lighting up. I'm going to keep the voltage low for a little while. I think if there were air in the envelope, it would have gone flash right away. And that's about 115 volts or so. Now we are up to 140 watts of draw here, and that was 75 or 80 for the power supply, so that's another 70 or so for this tube filament. Remember I said they draw 15 amps a piece, 30 amps for the pair of them. Which is about 300 watts, so I don't know, this seems pretty minimal. You have to remember that high voltage is on there. It's real tempting to stick your hand in there thinking, oh, well, that's not keyed up, nothing will happen. That'll kill you. There's 2300 volts or something there. 2400 volts. think if that was going to do anything untoward, it would have done it right away. Because when we put high voltage on it, it's a whole nother story. I guess I could have done two of them at once, but I didn't want to do that. And this is good, so this is getting me a reading. I might even write this down. Okay. So we got to go through this whole drill of waiting for this power supply to drain down. I could short it out with a screwdriver, but it's hard on the diodes and it's hard on the screwdriver, so. That sucker says 0 and there's 90 volts on there. Saw the spark, I think. Okay, it's unplugged, shorted out. Safe to stick my paws in there. Oh, those things do get hot. Ha ha ha, I forgot about that. Ow! Hot, hot, hot. Okay, so there's number 1. Alright. See, I'm still recording here. Yeah, okay. So, we'll do the same thing. Bring it up slowly. There's some color. Fan comes on. 75 volts, let it cook for a minute or two. Now there's full tilt boogie, and this one is drawing the same thing. The total draw here is about 140 watts. So this one also, Filament is drawing about 60, 70 watts. I'm going to call it 70, but whatever it is, it's the same as the other one. Well, unless these things start to grow like neon lights when I put high voltage on them, which means they're gassy, we're going to have good tubes. Well, what the filament emission is from each tube until we apply power to it and measure it. We do that individually with each tube and see what their power sensitivity is, and which is basically just giving it a set amount of drive and seeing what the output power is. We'll start with 10, we'll go to 25, then we'll go to 50. And we'll write that down for each tube to see if they're fairly well matched. And if there's no smoke, no sparks, no tuning problems, and most of all, no gas. We'll find out about the gas as soon as we put high voltage on them. We don't have to put any drive on them at all. No change in the power draw. It's just absolutely stable, just sitting there cooking along. So I think we're going to have a pair of tubes that's going to work fine. Of course, I'm only guessing about the gas, but I got a pretty good feeling that we're going to have a working pair of tubes here. Well, I don't think we're going to learn anything more here. So again, we'll turn this thing off and Let the bleeder resistors do their work. Next thing I'll do is put tube in and connect the plate cap to it. I guess I might just as well start with this one. Doesn't matter whether I do 2 first or 1 first. So all I have to do now is wait for the power supply to bleed down, connect the plate cap to this one tube, turn it back on again with high voltage on it, and if we don't, you can see on the internet where there's gassy tubes and they ionize, they just, all of the envelope just starts to look like a neon bulb. Very obvious, and of course they start to draw massive amounts of plate current. And so that's a very bad thing. But if we don't see that happening, I'm not going to be afraid to use the tube, or try to use it, apply power to it. But I'm going to test both of these tubes for gas this way, make sure they're okay, and then next time we'll apply some RF to this thing and see if it's actually amplifying, and we'll measure the power output of each tube individually, like I said, and see what we got. Okay, we're unplugged. The meter is down to 0. We know it's not really 0, but we'll find out what it is. What am I forgetting? Do not want to make mistakes while you're doing this. This meter will read up to 1,000 volts. It's saying 20 volts there. So use the magic screwdriver as a crowbar. Check it again. 1 volt. Okay, so what I'm going to do is attach this plate cap to this tube. Get my handy dandy little screwdriver in here, and I don't like having my hands in here like this. Okay, so there's the tube with the plate cap connected. So what we'll do, variax down to 0, plug it back in. We're on the tune position. We'll turn it on and we'll bring it up slowly. There's the filament. There's 1,000 volts on it. There's 1,500 volts on it. There's 2,100 volts on it. There's 2,300 volts on the plate. It is drawing now 150 watts, drawing about 5 or 10 watts more than it was. You can decide why. and I'm not seeing any evidence of any gas in the tube. I'm going to kick it up to high voltage. Okay, now we've got 3,000 volts on that tube. There's no neon business happening there. Not drawing any grid current. You can see a little indication on the plate meter. Well, I think that means the bias is working. We're drawing 160 watts right now. So that's up 20 watts from what it was doing with no high voltage on it. So it's drawing just a little bit of plate currents, idling along like it's supposed to. The bias has got to cut off. And I don't think we're going to have any problem with that tube. It was going to do something bad, it would be doing it, I think. That's more voltage than it's going to have on it under load. Because it's not drawing any current, but particularly, but $160 watts. With 3,000 volts on the plate. Okay. When you consider what iMac tubes cost, or any kind of new 3500 Zulu, I'm very happy. Very happy. If the other tube will do as well, I think we're going to have a viable amplifier here. Well, I guess it's time for me to go into dinner. Okay. Got the power supply all shorted out, my little safety jumper in there, unplugged. You just want to be methodical, and like my wife says, you got to learn to outsmart yourself. So that's what this jumper is. I was working on a broadcast transmitter. I put a jumper in there like that and forgot it and fired the thing up at 5 kW and blew up a lot of crap. But good news is I'm still alive. So clearly I wasn't being very methodical then. That's a long time ago. And what I'm going to do is move tube number 1 over here to this other socket. I tested both of those tubes in the same socket because I didn't want to introduce any variables at all. I don't think there will be any, but do not drop the tube. So I'm going to put number 1 on the right and number 2 on the left. So what we did previously was check the filaments on both of these tubes, check the tubes for shorts. We did the high voltage gas test on number 2, I'm sure. Can't remember about number 1, we'll do it again. We checked the grid voltage and the plate current with the high voltage applied, but just in the idling mode, not key down. So what we're going to do now is fire up the power supply on the amplifier again in the low power mode, the 2.4 kV, not 3 kV, and we'll check the plate current and the grid current again, and we'll key the thing. I haven't tested the relay to make sure it works, so we'll do that, but I'm sure it will. And we'll see what the idling plate current is and the grid current, which will be a test of the bias supply in the Harbach board. Previously, we've checked the idle cutoff for the internal bias supply that Heathkit provides through the winding on the filament transformer, and that's all working. So when we key this now, we'll be checking the key down idle current and making sure that nothing bad happens in the tube. So we'll go ahead and turn this on and bring it up with the variac. We're seeing about 125 watts of power draw. We're seeing 2600 volts. No grid current, and just a glimmer of plate current. See, if that's 100 mils, that's 10 mils. Be under 10 mils of plate current idling. Oops, wrong too. So now what we're going to do is we're going to hit the key, and we're going to see what happens here. You can hear the key. Grid current is not changing. The plate current is going up to about 15 mils, 20 mils. Okay, now I'm going to turn it to 3000 volts. Look at the grid current again. The plate current is up to 150 mils. Ooh, I wrote that as grid current. That's plate current. So I'm going to hit the key, look at the grid current. Nothing. Plate current goes up to 30 mils. I guess that's 30. Might be 50 mils. That's 100. Those must be 20, 40, 60, 80. So that's 20, 40, 60 mils. I'm reading this wrong. Okay, I'm going to go back to low power and read this plate current again because I had that wrong. Alright, so learn to read the meter right. The idling plate current with in the low voltage position is 30 mils, and if you key it, it goes to 40 mils. And in the high voltage position, the idling current is 40 milliamps. The plate current, it goes to 60 milliamps. Alright, so I'm going to turn that off. Turn the variac back down here, unplug it, wait for the bleeder resistors to do their thing, and then I'm going to swap tubes. And unless something drastic happens in the next 100 years, that's the way it's going to be. So, what we're going to do now you have to be careful about interruptions. My wife just called me on the intercom, and I reached up to get the intercom, knocked something off into the amplifier. Luckily it was a glue stick, and the amplifier was unplugged and discharged and everything, but beware of distractions. Okay, so now we've got both tubes in there, and we're going to put this thing on low power, plug it in. Come on, you pig. Turn it on. Make sure the shorting bar is out. Turn the variac up. Okay, so now we're showing 225 watts. $225 watts in the low power position. Really no discernible idling plate current. Which kind of surprises me a little bit. I'm not sure that this meter might be just a little balky at the low end. So I'm going to go key down and look at the idling plate current here. And that goes up to 75 milliamps. 20, 40, 60, 75. $75 milliamps. Grid current, nothing. Okay, right now, the plate voltage says about 2125, and when you go key down, it goes to 2 kV. And I'm also seeing voltage drop on the voltmeter over here, so this is not plugged into my high current 125 volt outlet, and it's running through extension cords and stuff. So okay, this is interesting. 225 watts is the idling AC power, and when you go key down, it goes to about 410 watts. So let's see, 20, 40, 60 or 70 mils at 2000 volts. About 140 watts idling input power, if you can believe this meter. It's probably not very accurate at the bottom of the scale. Alright, let's go to high voltage, run it up to 3 kV. Interesting. It's now, the B plus is now 2750 instead of almost 3000. Though the filament draw is dragging this thing down, as far as I can tell. So we'll see what the idling plate current is with on high voltage, and this should be quite a bit more. Yeah, that shows 110 mils. And the AC watt meter is going up to almost 600 watts. 110 milliamps. Now I'm going to check the manual and see if that's what it ought to be doing. And the plate voltage is going down to 2500. Going down quite a bit. We're reaching the, getting pretty close to the limits of the variac here. And I'm going to draw any more power out of this thing, we're going to have to plug it directly into 20 amp outlet and quit leaning so hard on the variac. The watt meter only goes to 800 watts, and I think the variac is only rated at 6 or 8 amps, so we're right at the limit of what the variac is going to do. Okay, so we're up to an idling current here with both tubes of 35 milliamps. So, anyway, I don't think we're going to have any trouble with these tubes. How much power they're going to make, I don't know, but they're not going to blow up.